Hello viewers, welcome to the third live session of this course on mathematical portfolio theory. We have released the contents for all the 12 weeks, and since the last time we have released since our last live session we have released contents on value at risk and risk management, and in particular I want to emphasize on the last week where we dealt with MATLAB, where we talked about portfolio optimization, portfolio selection, as well as value at risk. So you can use those tools so as to make your own assessment as far as the selection of assets is concerned, as far as the portfolio optimization is concerned, and as far as the risk management is concerned. So as I can see here, so far there is no question, no queries that have been posted on the spreadsheet. So at this point, I would like, if you have any queries, please post them on the chat box of YouTube so that your queries are visible to all of us and can be responded accordingly. So now I invite all of you to please post your questions in the chat box. So please remember that this session is limited only to an hour. So please post your queries so that they can be addressed in a timely manner. So we are looking forward to questions being posted by you. So I just hope that you have had an opportunity to work with the MATLAB component of the course the last week. Remember that in the first lecture we talked about asset allocation, and we looked at an example that was inbuilt into MATLAB of how the allocation of asset was done, bringing in several constraints such as the maximum cap on any asset class. You can set the amount of return that you are expecting. You can set the level of risk that you are willing to accept. In the second lecture of that week, we talked about portfolio optimization, and we also looked at how the optimization can be carried out, making use of constraints such as transaction costs and turnover constraints. And most importantly, we talked about uh, constraints such as the coordinatory constraints, as well as value at risk, which is a very standard benchmark that is used in order to assess the risk that your portfolio is facing over an immediate future time horizon. And at value at risk, we looked at three different approaches, how you can estimate value at risk, two of which were parametric, namely the one that was based on the first and second moments, that means the mean variance and covariance framework, and then we looked at the estimated weighted moving average (EWMA) method, which was essentially based on estimation of the volatility, and then accordingly also the other method that was approached, which was not method that was used was non-parametric. That was the historical method, where you assume that the future replication of the scenarios that you have is based on what has happened in the past. And then we looked at the various way of backtesting. So remember that backtesting essentially means that you look at a certain time horizon, and then you use the model to say, using the data say of the some first certain period of this time window. Say suppose that you are looking over a 1 year period, and you might just use the 9 months data in order to predict what is going to happen in the remaining 3 months. You of course have a data of 1 year. So what you do is that part of it you are going to use for prediction, and then part of it is you are going to compare with what actually happened in order to determine whether your testing approach was actually correct. So for example, if you were doing the parameter, if you are doing the projection or prediction based on 9 months data out of the 1 year data, and then you can make a prediction for the next 3 months, and with that and then of course you have the actual data of what happened in those 3 months, and you can compare both of them and see how good your prediction was based on the data that is available. And if your prediction is good, then of course you can go ahead with the model to make prediction of the unknown future. And if the prediction was not good, that means if the prediction based on 9 months data, the prediction for 3 months, that prediction is not very close to the actual reality of what happened in those 3 months, then of course you have to go back and have a relook at your model and try to rectify things so that you actually can improve upon the model that is better suited to make future prediction. So I again invite all of you to please post your questions in the chat box. So please remember, this is going to be the last live session. So this is essentially the last live interaction that you will have. So I encourage you to use this opportunity to post your questions. Of course, subsequently I will be addressing your questions that you post on the portal. So we have a small audience this morning. So I strongly encourage, since you are here, please use this opportunity to post your questions. So while we are waiting for questions to be posted from our learners, I'll just do a recap of whatever we have done in the course. Of course, there was an introductory video, but at that point of time, it might not have been completely evident as to what purpose will it serve, the specific choice of the contents. But now that you have been through this course of 12 weeks, let me just briefly elucidate a little bit on why this course was structured in this manner. So at the heart of portfolio theory lies a trade-off or an assessment of the return and risk. So return and risk have to be defined in terms of probability, which is the reason why we started off by discussing the basics of probability theory, both in discrete and continuous time, because eventually you realize that for discrete and continuous time, in both the cases we use models for asset pricing and consequent portfolio management. Then you talked about the financial market so that you have a sort of an introductory but collated uh, introduction and a brief overview of the basics of financial markets as a motivation to what we are going to study subsequently. Then we spent a couple of weeks talking about mean variance portfolio theory. Mean variance portfolio theory even though it's a long and well-established method, it still has relevance, and it's very easy to implement in terms of investment decisions. And then we spent about 3 weeks talking about the non-mean variance framework. So in the non-mean variance portfolio theory, we recognize the fact that the behavior of returns is not perfectly amenable or fits the setup for the mean variance framework. And so accordingly, we looked at several approaches how you can do the assessment in a more realistic way in the non-mean variance framework. Of course, the mean variance framework still retains its importance. Then you talked about the notion of optimal portfolio and consumption. Remember that in optimal portfolio and consumption, again was driven by the utility theory. So while we moved from the mean variance framework to non-mean variance framework, an important aspect of the transition was the introduction of utility theory. And then the utility theory played a very important role when you talked about optimal portfolio and consumption, where we looked at both discrete and continuous time setup using dynamic programming principle and Hamilton-Jacobi-Bellman formulation respectively. And then we talked about bond portfolio optimization. So very often in a narrative on portfolio theory, there is sort of very little to no presence of bond portfolio management. But you see, bond markets have become very important. So if you look at today, many of these big funds, such as mutual funds, not all money is put in equities. There are lots of investors who prefer not to have an exclusive investment in equities, and a part of the investment is put in bond. So given, and that is a non-trivial percentage. So given that and that consequent volume of investment involved in bonds, investment in bond as a part of a mutual fund, it has become also essential to manage the bond portfolios for a variety of reasons, such that the impact of the interest rate in case of in case of a decision being made to liquidate those bonds, and also from the point of view of the change of interest rate impacting the returns that will be obtained in case of the reinvestment of the interest. From that point of view, we looked at how one can carry out the bond portfolio management. And two very important concepts of bond portfolio management were the duration and convexity, both of which were a particular duration was an indicator of how sensitive was the price of the bond to the change of the interest rate, thereby which we recognize from the definition of duration that what we have here is that was that if the interest rate increases, then the price of the value of the bond decreases and vice versa. So from the point of view of a bondholder, you ideally want the interest rate to decrease subsequent to an investment in the bond. And then we talked about a bit about risk management. So risk management actually, if you go back to the history of risk management, you will see that sometime in the 90s, as the investment banks had their portfolios becoming larger and larger and more diversified, it was becoming increasingly difficult to manage the risk associated with the portfolios. So accordingly, JP Morgan came up with a formulation of what is known as value at risk, which at the heart of it relied on the mean variance framework. And it took them about 3 years to put everything in place, where at the end of the day they would have a single number that could be presented to the management as an indicator of the risks over the next 1 day or 10 day typically, but you could actually extend this to any number of days, and that would help the management make a day-to-day basis decision on how to handle the risk management aspect of it. And even though subsequently we have several situations where different alternatives to VAR were offered, which are very important, particularly from an academic point of view. VAR still has retained its importance again for the simplicity in its implementation and understandability. And finally, in the last week, we looked at some of the applications in MATLAB. So in that application part, what we did was that we looked at how MATLAB's financial toolbox, which by the way is has lots of features now, how it can be used in the context of portfolio management. And the advantage of using the toolbox is that in some cases, of course, we made use of the theory that we learned in the preceding part. But in addition, also, we were able to uh, uh, do a much more realistic addition of the problem framework, such as constraints, uh, so as to have a better assessment of a portfolio management and its consequent risk management. So the theory for those problems where you bring these constraints into the picture, that theory is considerably more challenging than what we have done in the course. But during the usage of MATLAB in a hands-on approach, you can actually implement those more realistic constraints that actually exist in market without having a detailed insight into the theoretical framework, which from the mathematical point of view is more challenging. So this sums up, that these are some of the topics, sort of. This is, of course, by no means an exhaustive topic, but it covers some of the most important components of portfolio theory that I would typically expect people to know. And I hope that people will find this beneficial, not only just from the point of view of learning, but from eventual implementation and looking for a career in this area. And that is what the eventual expectation out of this course is, where you actually have a mathematical background, at a sort of intermediate level, where you understand the theoretical aspects behind it, and then so that you can move on to the application part of it, an illustration of which was done through this last week, where we did the implementation using MATLAB. So again, that was just a brief summary, just a recap of what we had done, trying to motivate, why we did what we actually did in the course. And of course, I hope you now have a better perspective of the importance of this area. So uh, I again look at the opportunity. So far, again, I don't see any other question that is there on the chat box. So please, please post your questions to the chat box if you have anything. And if there are no questions, we can slowly look towards concluding the session. So kindly post your queries if you have any. Okay, so it seems that we don't have any queries from our learners. So I think we can consider concluding the session. And of course, you can keep posting your queries on the forum, and I'll try to address them as soon as I can. So thank you all for joining this live session. Uh, I hope you benefited and enjoyed the course, and it was indeed a pleasure to have brought this course to our learners. And thank you for the active participation during the course. And I will now conclude this last live session uh, by wishing you all the very best for your exam. Thank you for watching.